All right, it is 2 hours UTC, and that must mean, for no other reason at all, that it is time for Astronomy Daily Live. So hey everybody, come on in, join the crowd. Come on in. We're just gonna think and talk astronomical things for the next hour or so. So turn off the TV and forget about the news and let's just come in and think about the universe. Let's think about everything. And yeah, I like to do that as much as I possibly can. And I've been uh, um, usually, uh, well, I should start by saying that I'm located in southeastern um, Arizona, and and so I am 7 hours behind UTC.
Hey,
So
is your chat turned on or no? Because I don't see it on the app.
um, a, a chat on the on ours or on theirs.
Well, but usually you will have a chat. I don't see it on the app anymore.
Oh, I don't know. I don't know, Bobby.
Let me let me
I
try
see a
what's happening.
chat. Yeah, I see a chat. Um, so yeah, you'll have to hunt around or maybe restart it or something. I don't know. Anyway, welcome to Bobby too for coming in again. That's very very awesome. Thanks for showing up. If uh, um, if anybody wants to be on the panel, you can just send me an email to cosmiclettuce@gmail.com and say I want to be on the panel. And from that point on, every single time I um, start up this Hangout, I will send you an email with a link, and I guess you click on that link, and something magic happens, and we connect that way. So I think it's very very cool, and it'd be you know having the chat is really really great, and I keep track of that too. But having a panel probably is going to make this pretty lively. So yeah, the more the merrier. Of course, to be on the panel, you have to be coming in here live, and I know that isn't always possible. But yeah, uh, as I said, I'm 7 hours behind UTC, and so for me, it is 7:03 p.m. on the 18th of July, when in actuality it's 2:03 UTC on the 19th. That's one of the penalties, I guess, of living on a supposed spherical world. So just theoretical, though. You never know. So yeah. Uh, so usually this time of night for the past years and years and years, right? The day's sort of winding down, and I don't feel like working anymore. I'm usually up pretty early, and I work on my own projects until I have to leave for my day job, which is extremely awesome and extremely flexible. And it's even a thing where it's like, well, I don't feel like going in today, so I'm just not. I'm going to, and that's the best kind of job in the world. That really, really is. So extremely grateful um, um, for that. It has to be done because bills have to be paid. So no problem there. But at some point in the mornings, here I have to stop my own work and um, go work for somebody else for a little while in order to get some dollars to pay the bills, because everybody wants dollars, you know. Go figure. Everybody wants, you know, um, if I want their electricity, I they want my dollars. So it's like, okay, you know, I suppose that's a pretty good trade. Uh, yeah. So so usually I get most of my work done in the mornings, and I usually get home, you know, 5 or 6 or, you know, 4:30, um, and have a bite to eat, and it's like, ah, I just want to relax, right? So what I've been doing for actually years, right, is sort of um, uh, coming home and just thinking astronomical thoughts, and it finally dawned on me. I mean, it takes a little while for concepts to sink into this extremely dense matter up here. I call it neutron star matter, because that is the most dense material known, and that's exactly what is in here. So sometimes things take me a while to figure out, but I finally realized it's like, you know what? I can share this passion really really easily by doing exactly what I'm I've been doing for years and years and years. You know, sitting here reading astronomical papers, looking at pictures, thinking about things, you know, uh, trying to extend my knowledge and understanding, uh, and just having a blast. And so it's like, well, hey, let's just do this live every day. I mean, I'm doing it every day anyway. So yeah, you know, let's do it every day. And nobody else is doing this, so you know, it's filling a little bit of a niche uh, that wasn't there. And just like every other live stream, every other um, YouTube channel, this this is not for um, everyone. I'm not trying to cast a wide net, you know, and grab, you know, anybody who is willing, you know, to come along, or you know, gets caught up in it. Um, I'm uh, in a certain sense, I'm spearfishing, right? I'm like, there's one. I'm gonna go get that one. so so yeah, yeah. So it's a little bit of a different format than most, but I hope you like it. As I said, you know, it's very, very casual, but but you know, I am a scientist, and so when I look at things, I I try to sort of uh, carry along three characteristics at the same time, and that is curiosity, just intense, extreme. You know, what is going on here, right? Skepticism, because it's like, okay, what is going on here, right? And um, open-mindedness, and it's like, you know, whatever is going on here, this is pretty cool. So let's find out more. So yeah, that's what this live stream is all about. It's not necessarily about um, science communication or um, education or STEM or anything. Those those things I think will just sort of happen, and so that's not where my focus is. My focus is just having a little bit of fun for, you know, 1 or so hours every day, and you know, share it with a group of friends who um, you know, uh, in some way think alike, and I think it's absolutely amazing that we can connect like this. You know, I've um, uh, back in the late 80s, early 90s, you know, one would hear about this kind of stuff and it'd be like, huh, wonder how that's going to be, you know? And it's like, here we are, right? Um, so very, very cool. And it's extremely cool to have panelists because then it's like, you know, back and forth. We can see each other. You know, we can sort of, you know, pick up a different vibe, and it's extremely extremely cool. So thanks, Bobby, for coming on. Hope everything is going well with you over there.
All is well here,
Cool, cool, cool,
and
cool.
never give up.
Yeah, yeah. Well, you know, there's no point in doing that because that's just no fun. All right. Well, you know, I watched Tony Darnell's Deep Astronomy uh, show just now. In fact, just prior to coming on, I was just watching the end of it, and he had on a guy named Jason Major, and he takes images. Uh, it sort of looks like primarily from um, planetary spacecraft. So um, images of planets, and you know goes to the site, grabs the images, sticks them in Photoshop, and pretties them up. And I I'm pretty sure I'm following him on Twitter. Uncle Bill, I'm just catching up to the chat now. You're saying that you want me to add 30% to my output. Okay, I think I can do that. Let me do this. Yeah, you know what? It is naturally a little faint. So let me do that. How about that? Is that a little louder? I hope so. Am I louder on your end, Bobby?
Um, something like that.
Or can you tell?
I think you're mostly like the same.
Okay. Maybe people on the panel don't hear what people hear on the actual stream. Don't know. Don't know. All right. Well, cool. So anyway, it was Jason Major today, and really really uh, uh, pretty cool uh, show. There wasn't anything there that I didn't already know, but it's it's sometimes nice to hear uh, from you know those who you know sort of know more what they're doing, um, sort of hear you know the same steps you know that I go through you know to do exactly the same thing. So that that was cool. He he uses this site it's called OPUS, and hello there, Andy and Arenstro and Tom. I saw you um, earlier, and it's like, oh, there's Tom, but of course I didn't say anything, so I'm saying it now. Hey, um, okay, Uncle Bill, I can maximize me there. That's as much as I can go. That's as much as I can go. So, as I said, he uses this site called Opus, and I sort of thought that you know tonight maybe we go a little bit light and just do some sightseeing. Um, so I just started. Uh, I there's there's a lot of websites, right? I mean, there's lots of stuff, and but Opus. I'm going to share my screen, I guess. Hide that. So here it is, and let me. I can put the link in the chat to. I put it on my Discord server, so you can look there, but I'll put it on the chat here too, because I think this is a pretty nice. I think this is a pretty nice site. So there it is. It's it was put together by the SETI folks. They they do a lot of interesting things. So, but these are just planetary observations that were made by spacecraft that were going out. So, as you can see, there is no Mercury image here because uh, no spacecraft that was going out ever encountered Mercury. There were a couple of spacecraft that used Venus as a slingshot to get themselves out. But so this is a pretty easy site to use. What you can do, you've got all these what they're calling constraints, right? They're just parameters, right? And you can actually X all these boxes out, and then these are just boxes that'll pop up, right? Like that. So you know, and let's just dive into this. Let's do let's do Saturn. Okay. So as you can see, when I don't have anything selected at all, it actually shows you how many items are in this database, I guess you can call it. But when I choose Saturn, it drops to, oh, there we go, to that, right? And then that's quite a few too. So let's choose a mission. Okay, we've got Cassini, Hubble, and Voyager. Bobby, where should we go? Which spacecraft?
Let's do Hubble.
All right. So that's of course a telescope in Earth orbit. So these are going to be images taken of Saturn by Hubble. So that knocks it down to 2,611. Let's see, we can choose which instrument is used. There's only a few for WIFPIC 3, or the Wide Field Camera 3. There's WIFPIC 2. I don't remember what ACS, I don't know what that stands for. Let's go find that out really quick. Otherwise, I'm going to go crazy. For those of you who don't know about the space show that's called Tomorrow, TMRO, check them out. Check them out. They have a live stream every Saturday. I think, yeah, I want to say that it starts at 1800 UTC. So check them out for sure. They have a rule, right? And their rule is no acronyms. So you can certainly say the acronym, but you had better you know, say what that means. So ACS is the Advanced Camera for Surveys. So that sounds maybe like a pretty wide field camera. What is this? This is not helping me at all. ACS website. Third generation HST instrument. They're not going to instrument design, data analysis, software tools, instrument documents. Ooh, I don't know. That sounds. I just want specs, you know.
And
Overview.
the link that you give them on the chat, they say they're having a little bit of trouble accessing it.
Oh, huh. Hmm. Am I think I just did a cut and paste. Huh. Well, yeah, I'm not sure because yeah, I just did a cut and paste. Let me do this. I don't think this is going to change anything. But let me do just whoop. Left the T out at the beginning. See if you can just copy and paste that. Hey there, Totterbert. Nice to see you in the chat.
I think it's just Butters right now, Totterbird. I don't see how to log yet.
Let's see, can we get any info on this at all? Yeah. Okay, so yeah, it's actually really, really big. It's really, really big. Cool. Operating temperature, -81 Celsius. Wow. So it's got a 202 arcsecond square field of view. So that's what? Divide that by 60 on each side. You got about 3.5 arc minutes. Something like that. That's cool. Okay, so yeah, let's just do the ACS then. So we're going to be looking at Saturn through Hubble using the Advanced Camera for Surveys. So now, well, I guess that knocked it down to 1,600 images. That's still quite a few, but let's look at the results. So you just have to click on this, and it will present to you all the images, all of them. There's 17 pages of images. Apparently, these are all HST images of Saturn. I don't know about that. Okay, all right. So it wanted that little pound sign. Huh, that's a little strange. So you can click on each of these and it brings it up a little bit more, but then you can go to view detail. Yes, Totterbird, I've got a panelist now. I've got a panelist. Bobby Burgess is in the house. So yeah, you may hear him from time to time chiming in. So yeah, I'm not exactly sure what that is, but you can get, and what Jason Major does, right, is he goes in here and he grabs these kinds of images. And this is a pretty bad example, I have to say. I don't know. I honestly, I'm not exactly sure what that is.
I don't see
Don't
the
know.
ring.
Yeah, I don't know. Maybe it's out of focus. Yeah, I don't know. I'm not going to linger on this too much. Let's go back to browse results. Oh, and what they've done, and I, I don't, I understand why they're coloring them like this, because it's a lot easier for us, to sort of see that it's like, okay, that's a different wavelength, right? But and I think they try to match the color as close as they can to the wavelength being used. So I don't really know if I like the idea of doing that, but that's okay. That's all right. Anyway, so here's some HST images of Saturn. Um, looks like, uh, of course, multiple wavelengths. So in theory, and what Jason Major does, right, is he'll grab this one and this one and this one and this one, and he'll put them into Photoshop and make some extremely nice images out of it. But let's just take a look at one of these. And it's really, really cool, right? I mean, it gives you all the information, at least a lot of the information. The observation time, when the observation started, when it stopped. So, this was like a 3-minute exposure. Planet Saturn, mission HST, time, stop time again. It's not giving a lot of information here, but right ascension and declination. Well, I guess though that is relevant, but yeah, it's not here in this case. It's a lot of looks like there's a lot of info that isn't here. So for whatever reason, and yeah, this is looking in the ultraviolet. I sort of interpret this as well. I guess that would be microns. Yeah. So 0.2422 microns is 2422 angstroms. I think that's right. Yeah. So you can sort of see the wavelength band, and that is definitely in the ultraviolet. That's just a different way of representing exactly the same thing. Okay, so yeah, right. So the exposure time was 180 seconds, 3 minutes. What else they got here?
And no, Todderberg, I'm from Louisiana.
What's that?
I was telling Todderberg I'm from Louisiana.
Oh, okay, yeah. Just more. I mean, obviously, this kind of thing is probably automated. So they're just looking at data headers and all of that, and trying to get as much info as they can out of it. So in this case, it looks like I don't see a FITS header or FITS data. I see the FITS header, which is just all of that, but I don't see any FITS data. So yeah, this is a typical HST FITS header. So it's just the amount of metadata, right, is just absolutely crazy. It goes on and on and on. That's you know, Fitz header can be as big or as small as you want.
Now, can we go back on the search function and like switch it from the HST to the to that Christini or whatever that is?
Cassini?
Yeah.
Sure. Let's do that. So that's obviously got to be turned off. Okay, so now let's go. Sure, let's go to Cassini. So Cassini in every single way was a success. I think the imaging system is the ISS, and I don't know what that stands for either. Find that out really quick. This is definitely a something like a star party. Just no stars.
And I think
Bobby.
it's running around my location as well.
ISS. Okay, so let's see what this is. Imaging Science Subsystem. Okay, yay. So there's quite a few. There's going to be 400,000 of them. Should we try to narrow this down a little bit more? Let's look for intended target name. No, not intended target name. Because I don't think. What I guess what I'm looking for is. Okay, here we go. So here's a bunch of Saturn's moons. Let's see. Anything pop out there at you, Bobby?
I can see the Saturn. Okay, we'll go up.
Do any of those moons look interesting?
Hmm.
Do you know about this one, Iapetus? That's a pretty interesting one.
Yeah.
Let's try that one. Iapetus is a very unusual moon. One side is really, really dark, and the other side is really, really bright. So we're just going to scan down here. There's all kinds of weird things on here. And that's typical for raw data. You're going to have just sort of funny looking things that it's like I don't know what it is, right? Let's just look and see if there's any. I have no idea what we're seeing there. Hard to tell. Might be out of focus. That might be it, but I don't think so. Yeah, I don't know. All right, let's go back to the browse results. We'll just sort of scan down here until there's something moderately interesting looking. Not quite sure what all these are. If that's some kind of a calibration system, I'm not exactly sure. That's my guess. That this is just calibration data. Lots of calibration data. So there's something out of focus. Even the pros with the spacecraft can't focus their telescopes. Oh wow.
You ever watch Sanford and
Or
Son?
six
You ever
Sanford and
watch?
Son.
Yeah.
I wasn't too much of a fan of it. Of course, I know about it. Yeah,
Okay.
I guess these are images of Iapetus, but taken from maybe like the dark side. Okay, here's some interesting things. Didn't I didn't realize that Iapetus had a big crater. I guess it does. Yes, it does. I'm trying to see if we can find like a full image, not just a partial. You're sort of getting the idea here. See how it's dark here and light here. The the original Arthur C. Clarke 2001, A Space Odyssey, the book, uh, they go to Iapetus. They
Hey,
go to
talk
see.
about is your favorite line whenever Sanford said "you big dummy"?
Yeah,
You big dummy.
you big dummy. I'm afraid I say that to myself all too often. All right, still plowing through. This is just a whole bunch of just image after image after image. Come on. Not sure what we're seeing yet. This is kind of interesting though. Huh. This is the first time that I've ever looked at this site, so I don't know what to expect. See, I think there's a full full resolution. Kind of interesting. You can see how it's really light here and dark here. Moon of Saturn. Let's see. Let's go back. Oh man, we got to go all the way back. That's bad news. Let's go to number 20.
Tyler Bird, for a dummy, you make a lot of sense.
A lot of sense. Well, this is just going to be a pretty light live stream. We're just doing some sightseeing tonight. This Tony Darnell had Jason Major on, and he sort of pointed us to this site, and I started looking at it. And it's like, oh, all right, that's what we're going to do tonight. So this is the moon Iapetus as imaged from the spacecraft Cassini, which of course is no longer with us. Plunged into Saturn last September. epic. What an epic end. Right on, right, just absolutely fantastic. It's the right way to end that. Of course, it's sad, but you can't be sad when you know you get this kind of stuff. Even the out of focus images are moderately interesting. Oh, where'd all my oh, I don't know where they went. Let's see. Let's look at page 50. Okay, so there's sort of the whole thing, but it's a little hard to see. Oh, sorry about that. Come on. So let's. One of the interesting things that Jason Major mentioned was that when he grabs these IMG files, uh, uh, for some reason they come over as .txt files. I'm not exactly sure why that would happen, except that his machine might be adding that extension on there because they are supposed to be um, IMG files. That's a particular format. It's a lot like FITS in that it's got like a text header and then a bunch of data afterwards. I don't know exactly why they would use this as opposed to FITS, but it looks like a lot of the data, especially that is coming from PDS, which is the Planetary Data System. A lot of the images are in this IMG format, but yeah, so he's just grabbing those, changing the extension to a .raw, and then importing them into Photoshop. And that's all he's doing. But let's look at the JPEGs here because, of course, those will load on the browser. So there's Iapetus, one of the moons of Saturn. So cool. Let's see. So let's go back to search. And let's see. Let's move away from Cassini. In fact, let's oh, let's do it. Let's look at Pluto. So there's probably some HST images of Pluto, which a lot of people haven't seen. Would it be here? Hubble. Yep. Quite a few. I want to... Is it a mission? No, instrument name. So wide field camera 3, there's quite a few. So let's look and see. So these are HST images of Pluto. And this is going to be a little bit of everything, so who knows? Probably is Pluto, but it's too hard to see anything. I know that there are some pretty good shots. Let's see. I'm hoping that we're just going to sort of get lucky here. But, yeah. Pluto and pretty faint. Even for the HST. But we're down here a little bit and see. So far, I'm not getting much joy. Seeing lots of really, really small dots there, but I thought there was more. I thought that they had some higher resolution. Did we use? Yeah, we used the wide field camera. Let's take a look at this one. You never know. There's only 30 of them. Not seeing too much there either. Yeah, that's all there is. Thought there were some pretty good shots of Pluto. I could be wrong. Come on. Let's look at the last page. Yeah, wow, just not seeing much. Should probably give this a good college try here and grab at least one of them. These sort of, it's probably hard to see on your screen, but these look like they're saturated, but this one doesn't, and this one doesn't, this one doesn't. So I don't know. Yeah, that's it. That's it. So one has to assume that that is Pluto there, but it could be one of these others as well. Not sure. I would think it would be the object closest to the center, but I thought they had some better shots of that. I have to investigate that a little bit more. Let's see. I would think that New Horizons would probably have some pretty good shots. Not quite sure what these are. Probably part of the calibration, I guess. Kind of interesting, huh? What is that? I've never seen any of these before, so I have no idea what to expect. Those look like darks. This might be flat fields, maybe.
Do you subscribe to space videos?
Oh, Bobby, yes. Is that a YouTube channel?
Yeah.
Yeah, I think I do. I don't remember.
They did have a live stream of the new Horizon images and stuff, and they were pretty darn good.
Oh, cool. Yeah, I'm sure they're just, you got to get through all the, and there's probably a way to to actually filter through all of that.
And check Uncle Bill's comment.
How come Hubble images of Pluto are so blurry as the galaxies in such detail? Yeah, that's right. That's exactly right, Uncle Bill. There's got to be a way to sort of narrow this down. No, not like that. Yeah, Uncle Bill, I thought that there were just a few more pixels though, as opposed to just a few. Could be wrong about that. All right, well let's maybe dive in a little bit deeper here. Go to page 26. That's about halfway. Okay, well, let's go to oh, come on. Go to 46. Well, I hope all this data is useful because you know, it took them like a year and a half to download all this data from the spacecraft. And I don't know, it seems to be a lot of calibration data, if that's what this is. Huh. Well, oh, I guess I'm not sure what I'm seeing. Let's go. Can't be sure if that's Pluto or if that's something else entirely. It might just be some background stars, but no, I guess it's getting brighter. Let's follow this path a little bit. Oh, here we go. Okay, so there we go. We're getting something. Is that Pluto or is that Sharon? It's got to be Pluto. Okay. So here's some images of Pluto that you may have never seen before. I know I haven't. Let's see. I think there were. Oh, it's going to go all the way back, isn't it? Oh no, it didn't. Okay. Oh, it did. Here we go. Okay, so let's take a look at a few of these. I think these are probably sort of the ones that everyone has seen, but it's nice to see them in sort of a raw format from the horse's mouth, as they say. Slow connection. Pretty nice, though. Pretty amazing, of course. Kind of neat to see the raw data, though. I like it. Let's see. Can we go back one? Here, go back one. Pluto looking raw. Let's do 34. Hiptacular Raptor is in the chat. Nice to see you there.
Long time no
Everything is
see.
well. Yeah. You are welcome anytime, Hip. Anytime you want to drop in, you feel free. We're looking at Pluto. Just some shots from the New Horizons spacecraft. Just taking a little bit easy, just doing some sightseeing on the porch. So pretty amazing, of course. Weird looking crater here. I mean, I guess if that's what you want to call it. Kind of funny looking. Everybody's very, very surprised at as to the lack of craters, right? The idea is that if there's a lot of craters, then the surface and probably the rest of it is really, really old and hasn't really changed much. But lack of craters means the opposite, right? That there's either current activity or at least recent activity, and we've got this whole area right here which is just no craters, right? So it's like, what's going on? I don't know. That's kind of a cool one too down here. These big cracks, big nasty cracks. And yeah, I mean, I don't think that they would be characterized as cracks. They're oh, what would you call that? Just sort of carved out, you know. Let's see. I'm trying to. Is there a way that I can get back? Because if I do that, oh, okay, it does. It brought me back to where I started. Oh, so now they're getting really close. And these are probably the shots that a lot of us have seen. This one I haven't seen before. I think this is Sharon. Pretty sure this is Sharon. This is still Pluto, but I think this is. We moved on to Sharon for a little while here. It's like they moved back to Pluto. Those close-ups, you know. Check it out. Oh, I got a whole bunch of them here. Ooh. Guess these mountains are very, very high. I don't remember the numbers that they gave, but you know, like uh, thousands of feet high. Um, I guess made of ice, made of water ice. But it's so cold. It's like as hard as rock. I don't know if that's a guess or if they have some actual data on that. But yeah, pretty interesting looking crater here. It almost looks like Arecibo down there in the middle. That's a nice smooth radio dish there. You see that? Yeah. All right. Now we know. Now we know what's going on Pluto. That's a cool shot, though. See this over here? Look at that. It looks like some kind of, rippling effect or waves or something. That's kind of cool. So this is a pretty cool site. I sort of like it. It's limited, right? In that it's only uh, uh, data from spacecraft that were going out. So that's not you know uh, all the data that comes from the spacecraft, right? These are just the images. So these spacecraft also have magnetometers and spectrometers, um, all kinds of other instrumentation that that data is not here. Um, Now, the one place that you can get all the data is from the Planetary Data System, which is, yeah, it's just pds.nasa.gov. And Jason Major said that on a scale of 1 to 10, getting data from the PDS, if 10 is the hardest, getting data from PDS is like a 7 or an 8, and getting data from OPUS, he said, is like a 5 or a 6. And yeah, I've played around with OPUS now for a couple hours, and yeah, it's pretty easy to move around. It's a little bit easier than PDS, but the PDS has everything, right? So, like Cassini just came out with a new data release, which actually goes to the end of the mission. And you can see that, there's image data. Let's see, which one is the, it's ISS, isn't it? ISS? Let's see ISS here. Anyway, lots of instruments, right? Dust, magnetic field, chemistry, spectrometers, as I said, yeah, radar. So yeah, if you want any of that data, you've got to go to PDS. But to represent this other kind of data, that isn't image data, in sort of interesting, understandable way, isn't quite as easy as it is with working with images. So, all right, I think that I'm gonna call it. Let's see, can I get back over here? There we go. Yeah, I think it's been a good hour, and I've consumed very, very, very little of this HOH, which is terrible. So cheers. Awesome. Freshly brewed too. So, all right, well, cool. Yeah, I think that's gonna do it for tonight. Yeah,
For show.
thank you. The yesterday I was working a little bit late, and I knew I was going to be a little bit late. And you know, the one thing, there are very, very, very few things that I actually like. You know, I would say that I hate, right? But one of the things that I definitely do hate is hurrying or rushing. So you know, uh, if I can't do one live stream once in a while, because I'm going to have to hurry in order to get there on time and all that, it's like, you know what, we're just going to chill. So yeah, from time to time, the live stream will not occur, but I would say most of the time, yeah, because I'm I'm here anyway, thinking and talking astronomical things. It's kind of cool looking at the OPUS site. Definitely want to dive into that a little bit more. They certainly have a lot of data there. It looks like a lot of calibration data, which makes sense, right? I mean, if you want to be able to do science with that data, you have to know um, what those numbers mean, right? And so you have to take everything out that could be part of the instrumentation, um, or noise, or some other kind of bias, so you just get that measurement of the object that you're looking at, um, and that takes a lot of overhead. And so yeah, there's a lot of data which is otherwise just sort of junk, but it's I would think that most of that data isn't junk. It's just calibration data, and it's pretty not too interesting. So, but yeah, that's the process of science. A lot of it is very tedious, and just looking at blank images like that, because that's what tells you what your instrumentation is doing. So, all right, with that, I'm going to get out of here. So take care, everybody. I will see you in a little less than 23 hours from now, just a little less than one spin, all the way around. At the equator, uh, we're traveling like about 1,000 kilometers an hour. It's just mind blowing. It's just incredible how we're moving, and we're just completely not aware at all. Can't feel a thing. Try as hard as I can. I can't feel it, but you can certainly see it, right? You look up in the sky, and the sun seems to be moving, but that's not the case, right? It's us that is, and that's just incredible. Yeah. All
That's
right.
the way it is.
It's just the way it is, but it's very, very cool. Glad to be here. All right. Take care, everybody. I will see you on that spin. One more spin. 2 hours UTC tomorrow. All right. Take care. Bye.